So we're back with hour 1 of lesson 4. So we're having a look at our SQL Server video. Oh, thanks. This is the Gulf Coast of Florida. I took this photo. My family and I like to head down there in winter when we can. Took this a few years ago. Haven't been down there for a few years. Yeah. I'm not so good with the shadows, though. I'm no expert photographer, but it's called Sunset Beach for a reason. So how popular is SQL Server? Well, let's have a quick look. So this is from dbengines.com. So they rank almost 400 database systems, and they update this monthly. And you can see a couple interesting things about SQL Server. Number one is that it's one of the big three, along with Oracle and MySQL, and they really sort of dwarf the other systems. But you will notice that trend-wise, all three of these are trending downwards, basically from the past year. So we're seeing big increases in some other database systems like PostgreSQL, MongoDB, and Redis, which is for caching. And MongoDB is something that you're going to work with in your, if you're in computer programming, in your JavaScript frameworks course, if you're in the web program, in our advanced server-side scripting class with Mean, we're going to work with MongoDB in January. And you'll notice all of these are relational databases, whereas MongoDB is a document database or a NoSQL database instead. But SQL Server is still one of the most common database technologies in the marketplace. So I've posted these slides up on Blackboard. There's not very many of them. I'm just going to go through a few things here. Well, there's the link to our video and same screenshot we've already covered. I've documented here for you. We did go over this in class last week, but I've documented the process of creating both a local database as well as a database on Azure. So you would do both of these ideally through Management Studio, which we installed at the end of class last week. You'll connect to your local server, typically using Windows authentication, which means you don't need to put in any kind of username or password. And then you just connect to your server and right-click your database and choose New and give it a name. So we did this in class last week. So to show you what this looks like, if I open Management Studio, you don't have to do this now if you did it last week, but I'm just going to go through the process again. It should bring up my local server name, which is my computer name. It should default to Windows authentication. All I have to do is in the Connect to Server window is just click the Connect button. And it connects me in this window called the Object Explorer. So if I wanted to make a new database, I can expand and see here's the Positive Pets database I made last week. So if I just wanted to make a new one, I just right click, choose new database, and create a Thursday test. And click OK, and I have a new database. Pretty simple. I've also documented the process we went through in class last week that you'll need to do for your assignment about how to create a database in the Microsoft Azure Cloud portal. So you'll create a new server, you'll choose the free or basic tier, and then you'll create the server name, which will be some kind of prefix. And Microsoft will automatically give you the address.database.windows.net. And then you'll name your database and create a username and password for it. And as we saw when we did this last week, and if you missed this, this is in the lesson 3, part 3 video. We'll also have to set a firewall rule because by default, Azure does not allow remote connections to the database. So we created a firewall rule to allow all IP addresses in. And then the instructions of how we would connect through Management Studio are documented here as well. So if I want to connect to it, I can just open up my registered servers, and here's my my pet store database that I created in the Azure portal last week. So I've actually got two versions of the database. I have a local copy as well as a copy running in the Azure portal. So we did this last week, but I've documented all the steps here. You can find this documentation on Blackboard right here, this week 4 slides. So you've got this as a reference should you need it. So we've kind of done this stuff already, but what we want to look at now is setting up our web project and then connecting it to our SQL Server database. So we've got a few steps involved here. The first thing we're going to need to do is we're going to need to create all of the models, figure out what model classes our pet store is going to need. And we have to design those models. So I guess that's a two-part. First, we plan it out, we design it, and then we build the models. Second step. The third step is we're going to have to reference all of these in our database connection. We've got to put our connection string into the web project, and then we're going to use this migrations tool that will copy the models in Visual Studio into our database. And then our web project and our database are going to be able to talk to each other, which is something in week 2 in our discussion board at the end of class. We had this brief activity and I asked people, what are you most interested to learn? And the most common answer I got was, well, how do we work with the database? So that's what we're going to tackle today. So let's do this little exercise together, okay? I'm going to open up our project and get it running. So open up your Visual Studio. We'll open up our Positive Pets project. And I will start it from my debug menu. I'm going to start without debugging to get the site loading in the browser. So this is where we left it last week. We've got our home page. We had our list of categories. And we also scaffolded out. We auto-generated this category form. And we included some validation rules here. So this is what we did last week. So I'm going to close up all my files for now. The only one I'm going to leave open is our category model class. So we're going to focus on the models for now. So we've created an application. I've created an empty database, both locally and on Azure. But right now, the only model we have is a category model. Just close everything up here, other than models. So we are going to need this because we'll want categories in our store. So let's go ahead and design. We can do this collaboratively, and this is part of what you'll have to do for your assignment. Pet store ERD. So why don't we start by figuring out, you can use this entity relationship template, what other models do we need in our pet store? So models, or i.e. tables in our database. We know we've already got a category table, so I'm going to drag it on here. And you probably made these kinds of diagrams last semester in your relational database course. So we've got a primary key here called category ID. I will save this file so we all have access to it. So this is kind of what our categories table is going to look like. What other tables do we need in our Positive Pets store? What would be another table we're going to need to put in our database? Okay, so we could have pets. Sure. Okay. So we'll have pets. David, I'm thinking we could probably use the categories for that, maybe, right? So we could have, like dogs, cats, fish. We could do it as a separate table, but we could probably use our categories table for that. Okay. So we'll have a pets table, we'll have categories. What else? Yep. So our primary key will be pet ID, and the D is lowercase. So the naming convention is always Pascal case. Okay. What other tables do we need? We'll come back and design this table a bit more in a minute. So we've got categories and pets. What other tables do we need in the database? I can think we're going to need at least 3 more. Yes, we are going to need a customer table. That table we don't actually have to design. That one's going to be auto-generated. And we'll look at that a bit later, Gio. So I'm going to leave that one out just because we won't actually have to build that one. But good idea, we'll definitely need it. Okay. Ralph, we may need a services. Yes, let's think about that one. We definitely need an order table for sure. Someone wants to adopt a pet. So again, here we'll have an order ID. Okay. Anything else? Any other tables we need? Ralph, I'm going to think about services. Come back to that one. What table will we need? Okay, and do we do supplies? Yeah, so you know what? Maybe let's just think about this for a minute. Just for simplicity, our store could work in one of a few ways, and all the suggestions we've got. We could actually sell pets themselves, we could sell services, or we could sell products. Each of those is going to be quite different. For simplicity, I'm going to recommend we maybe just sell one of those 3, either pets or pet supplies or services. Just because I don't know we'll have time to build out all those different things, those different product and service offerings. So any suggestions? Which one would you like to do? So we could have pets, we could have services, or we could have supplies. Okay, so maybe we'll just feature the animals itself, and nothing wrong with the suggestions. Those are great suggestions from Ralph and Kat, but just to kind of manage the scope, maybe we'll just sell one thing if that's okay. Okay, so we've got categories and pets. We've got orders. I can think of 2 other tables we need. What table will we need as someone is shopping, but before they finish shopping? Yeah, I agree, Keneal. We'll need a cart table. We'll call it cart items, maybe. Okay. So we've got our categories, where breeds, our type of pets. We've got the pets. We can shop. We can put pets in our shopping cart. Order. Then we can order. So we need one more table. What will we do if someone? Okay, close, Keneal. Let's think about the relationship here. Right? let's say I want to buy 2 fish and a bird. How many cart items would I have? Right, so I'm going to have 3 records. Thanks, Kat and Jordan. I'm going to have 3 records here. But then when I go to order, I need to include all 3 in here. Right, so how would I represent multiple pets in this one order? I think we're going to need another table for this. What would that table be? Yep, Tushar, we need another table. So what might we call it? It would be related to the order table, but each record would represent one item in my cart. Yeah, thanks, Gio. That's exactly what I was thinking. An order detail or order items. So then I've got, order details, and this should be called orders. And notice my table names are all plural. So here we've got order detail ID. Okay, so let's flesh out what these will look like now. We've identified the tables. Now we need to identify what are the properties or the columns in each table, like we've already figured out in categories. So step 1 is list the tables or the models. Step 2 is list the properties or columns in each. And step 3 is going to be figure out the relationships between the tables or models. So let's go back to our pets. So every pet is going to have a pet ID. What other columns or properties do we need for each pet? Okay, we're going to have a name. Thanks to you. Yep. What else do we need to know about each pet? Aha. We're going to need to link it to a category. So I'm actually going to do that one. Oops. I'm just going to undo that. I can actually add here. Right, so every pet should be in a category. What other fields do we need in here? I can think of probably minimum of 2 more. Okay, yeah, we might color. Yep. Age. Thanks, Jennifer. Now it's a store. So what else do we need? Thanks, Jennifer. Again, yeah, we're going to need a price. You. The other thing we're going to add later on, I mean, who's going to buy a pet if they can't even see a picture? So this is probably good. I mean, there are other things we could add, but probably this is good enough. So for each pet, we're going to have an ID, name, color, age, the category it belongs to, a price, and a photo. Okay. So let's define our cart item model now. What does this look like? What information do we need when someone puts an item in their cart? Okay, so yeah, I think we'll use the ID rather than the name because it's related. Okay, so I'm seeing lots of suggestions. We've got the name. So we'll add the pet ID. So I'll add that foreign key here. We're going to need to know the quantity, right? Maybe I want to buy 3 clownfish. So they may not have a name, for example. Ralph, we can get the breed through here, right? Because if cart item has the pet and the pet belongs to a category, we can get it that way. Yep, we can get the price. So the total we can figure out by multiplying the quantity by the price. Now we need one more thing. Let's say that both Ralph and I are shopping and we both want clownfish. So Ralph puts 2 clownfish in his cart. I put 3 clownfish in my cart at the same time. Well, Tushar, the order doesn't exist yet, right? The order ID won't get created until we actually check out and pay, whereas the cart items are as we shop. So I think in here some way we need, as you suggest, we need the customer ID, don't we? Right? So if Ralph and I are shopping at the same time and we both put the same pet in our cart at the same time, we need to separate out whose cart is whose. So we need to connect the cart to a customer. Yes, we can grab the price, but it's a good idea for us to put it in here as well, because the price could actually change, couldn't it? So probably not a bad idea to include the price. We'll basically just copy it when someone puts it in the cart, because maybe it's on sale now, right? It's a one-day sale. It's 20%, goldfish are 20% off. So I put them in my cart today, but maybe I don't check out until tomorrow. So I want to see that I put them in there, for example. Okay, so there's our cart items. Let's go down and define an order now. So Tushar, this is, I think, where you were going. So first I browse the list of categories. I find some pets. I find a pet I want. I put it in my cart, and then I go to checkout. Okay, so yeah, we're going to need some information about our customer for sure. So the order table is probably going to be pretty big. So I'll add those fields in a minute. So we'll definitely want things like first name and last name. Oops, hit the wrong key. We'll have an address. Well, the order details will be the individual items ordered. So these are the things that pertain to the order as a whole. So I'll have the city, province. Yep, Ralph will want that as well. Postal code. I'll put in phone and email. And yeah, Tushar, we could have maybe a payment code. So some kind of payment confirmation that connects an online payment to a particular order. So if the customer calls and says, hey, I have this transaction code on my credit card, but I don't know what it's for, we could search the order table and go and find, say, hey, well, here's the order that you paid for. I'm also going to add here the order date and the total. So all of this information is about the entire order. It doesn't matter whether the customer orders 1 pet or 1,000 pets. They're going to get one order confirmation ID with a date, a total, and then their contact info here. So now we can define our order details. What columns would we need in order details? So again, let's say I buy 3 different pets. I'm going to get one order with one date, one total, and my contact info, but then I'm going to have 3 records in order detail. So what would each order detail record look like? Okay, yes, Tushar, we're definitely going to need the order ID foreign key, right? So we can connect up. Now we could just connect the cart, or what might be a little more efficient is to just copy the items from here, and then we can delete the user's cart, right? Once they've paid for it, if they go back to their shopping cart should actually be empty. But we could basically just copy let's see, so we get we could add one more foreign key here. So we've got the order ID and the pet ID, and then also the quantity and price. So I think this should be everything we need. So now we just need to go ahead and we've identified the foreign keys, but now we can actually make the relationships. So we've got one category, right? To one category has many pets. So I can just drag, and now I've got this relationship. One pet can appear in many carts. One pet can also appear on many order details. And one order also has many details. Maybe I can move these things around a little. Oops. Okay, I'll just leave it as is. So there's our diagram that represents the database we're going to build. So we're going to have 5 models, and we're going to have 1, 2, 3, 4 relationships. So every table is in some way related to one of our other tables. So I'm going to save this diagram, and I can actually put it up on Blackboard so we can use this as a useful reference. Oops. So I'm going to download this. So there's our pet store ERD. And I'll upload this to Blackboard so we have it as a reference. So this process that we just went through, this is fairly similar to what you'll need to do in your assignment. Now, our database is probably bigger. You really only need 2 tables. You can have more, but you don't need more than 2. So if we just go ahead and have a look at some of the project submissions. So this project, car battery, so you'll have probably a car model and a battery model. Skincare, there'll be a problems model and a solutions model, right? So one problem may have many solutions, for example. Here we might have cats and adoption requests. Here we might have, travel plans and budgets. Or video games would be one model, and platforms would be another model. That one game is available on many platforms. So you'll need to go through, use kind of the skills you have from your relational database class to go through this process of designing the models you need for your site. And if you need help with this, then I'm happy to help you. You can feel free to send me an email and ask for some guidance or set up an appointment, and we can go over this exercise together with your project. So most of the actual brain work in assignment 2 is actually this part. It's figuring out what tables do you need, what does each table look like, and what are the relationships between the tables that you'll need to build your site. So here we'll have probably like players and statistics. So everyone's database is going to look different. So it's 11:50. We are about due for a little break. Are there any questions about our database diagram just before we take a break? There's no absolute right and wrongs here when it comes to designing your database. It's a little bit art and a little bit science. So some people might have taken this same pet store and designed the database totally differently. That's fine. This is just sort of how it works in my brain and in our kind of collective brain with the feedback you've given me and your suggestions in the chat. This is by no means the only right way to plan out this database, but I think it will work for our purposes. All right, let's take a 10-minute break here. So when we come back, we're going to implement the model classes with the relationships in our web project. And then we can build out the database tables from there. Okay, so we will do that when we come back in 10 minutes.